Hello and welcome back to our channel. We received this question recently. How are applications, application functions and application service related? And are they all required for 5G applications? The answer is, it depends. Let's try and explain in this video. If we take any mobile network, and even though I say generation, it may be easier for most people to understand this as 4G or 5G network. There is a default bearer that is established when there is packet data to be sent. The default bearer is a non-GBR or non-guaranteed bitrate bearer that works on best effort basis. For other operator-supported services, we have two dedicated bearers that are set up. One for signaling of the service and one for the data part of the service. If you know, for example, how voice over LTE or VoLTE works, there is an IMS signaling bearer with QCI 5 and there is a voice call bearer with QCI 1 that is established. This is a native or inbuilt application which is part of the mobile network architecture. We have a popular video looking at all the different voice options. It recently crossed 10,000 views. The link is in the top right corner. We also download apps on our devices like tablets, smartphones and even smart TVs nowadays, as long as there is data connectivity available. The data connectivity could be from mobile technology like 3G, 4G or 5G, or it could be from Wi-Fi. These apps like WhatsApp, YouTube, Skype, Netflix, Telegram, etc. are referred to as over-the-top or OTT apps. In this video, because we are trying to understand the applications from mobile network point of view, we will ignore the Wi-Fi connectivity part and only look at the mobile data connectivity option. So the OTT apps on our devices connect to the server in a data center or cloud. The app is responsible for both signaling connection as well as data connection related to that application. All the information on an OTT app is carried over the default non-guaranteed bitrate data bearer. So, in summary, we can say that from a mobile network point of view, there are native or inbuilt trusted applications and over-the-top untrusted applications. As you can see, examples of trusted applications include voice and video telephony, SMS, MMS, V2X applications, XR applications, etc. Some of these may have been defined in the standards, but have yet to be implemented in live networks, while others are being standardized as we speak. Untrusted applications include internet browsing, WhatsApp, YouTube, Facebook, Instagram, etc. We have looked at the 5G service-based architecture in one of our tutorials before. The application function AF, which is relevant to this tutorial, handles the signaling part for the application server. It interacts with this 3GPP core network in order to provide services. The application function can either be inside as part of the control plane function group or outside. It all depends on if a particular application server resides in the trusted or untrusted data network. Let's understand what this means. Third-party applications are applications that have been approved by the operators to use the operator core network, either directly or via access to exposed API. A trusted application resides in the trusted data network and would use the network repository function NRF for communications with the core. An untrusted application resides in the untrusted data network and would use the network exposure function NEF. This is just another view depicting the application server resides in the untrusted data network, so the application function is shown outside the control plane function group. Let us now look at some examples. Let's take this example of 5G extended reality or XR application. We are not explaining here what XR is, but feel free to check out our tutorial on that topic. This slide shows the 5G XR functions integrated in the 5G system. On your UE or device or smartphone, etc., you would have a 5G XR client, which is UE internal function dedicated to 5G XR services. 5G XR AF is an application function dedicated to 5G XR services. 5G XR AS is an application server dedicated to 5G XR services. The application function manages the control plane or signaling messages. The examples of these can be where you start the application, it has to check you have the permissions, credentials, check the policies for charging and billing, etc. The actual user plane data flows through the application server. As you can see, the architecture shows trusted data network as well as external untrusted data network. Functions in the trusted data network are trusted by the operator's network. Therefore, application functions in trusted data networks may directly communicate with all 5G core functions. Functions in external data networks may only communicate with 5G core functions via the network exposure function, or NEF, using N33. Here is an architecture diagram we looked at in our Vehicle to Everything, or V2X tutorial. The UEs here are the vehicles. The V2X applications would reside in the vehicles, which has the 5G modem. Of course, it would be optional with some subscription-based model. The application server would reside in an external trusted data network. 3GPP TS23.287 clarifies that V2X application server includes application function functionality. The text on the right-hand side details what the V2X application server does. You can see the slides on our SlideShare channel and go through them at leisure. We blogged about drones or unmanned aerial vehicles, or UAV, in one of our earlier blog posts. The white paper referenced in this post shows the architecture you can see here on the right. We won't go into any details here, but you can see the various nodes that are required. Finally, this is the multi-access edge computing MEC architecture in the 5G service-based architecture. As you can see, MEC would typically be trusted data network, so the application function would talk to the PCF over the N5 interface, and the edge cloud or data center would be connected to the user plane function, or UPF. In our private networks tutorial, we explained how in some cases, the private enterprises and factories may want to retain their data locally. This would be possible due to this kind of MEC platform. The MEC platform would perform traffic routing and steering function in the UPF. The PCF and the SMF can set the policy to influence the traffic routing in the UPF. Also, the AF via the PCF can influence the traffic routing and steering. Therefore, MEC in 5G is able to influence the UPF through the standardized control plane interface in the SMF in a similar way to how some of the EPC MEC deployment scenarios do in 4G CUPs. Here are some links for further reading. The slides can be downloaded from our SlideShare channel. See link in the description. So we hope this short video clarifies the role of application functions and application servers in the 5G network architecture. Please feel free to leave your thoughts in the comments. If you like this video, make sure you give us a thumbs up and please do subscribe to the channel. Thanks for watching and see you again soon. Goodbye.